Hey, here we go. Lesson 4 from Unit 3 in AP Calculus coming at you right now. We are studying how to apply the quotient and product rules. As is going to be the way we usually do it, we'll spend one lesson going over rules. The next lesson, we'll apply them, see what we can do to solve some problems. And I got some good ones for you today, so I hope we enjoy. First, start you off with a practice problem with given that g of 2 equals 3, g prime of 2 equals negative 4, h of 2 equals negative 1, and h prime of 2 equals 5. I would like for you to evaluate each one of these questions for A and B. So pause the video right now and give it a try. Okay, so let's see how it went. Hopefully you had some success. All right, well, we're given that f of x is g of x times h of x, and we want to find f prime of 2. So I find f prime of x and then plug in 2. What is f prime of x? Derivative of the first times the second plus the first times derivative of the second. Now let's plug in 2 for x. So f prime of 2 is equal to g prime of 2, h of 2, plus g of 2, h prime of 2. G prime of 2 is negative 4. H of 2 is negative 1. G of 2 is 3. H prime of 2 is 5. So this is 4 plus 15 is 19. All right, q of x. We need to find q prime of 2. So we've got to find q prime first, right? Low, d high, minus high, d low, all over. Oh, wait, I'm missing my d on my d low. All over low, low. All right, let's find q prime of 2. And I'll just skip right to playing 8 in. So h of 2 is negative 1. G prime of 2 is a negative 4. Minus g of 2 is 3. H prime of 2 is 5. All over h of 2 squared, which is negative 1. So negative 1 squared. So that becomes 4 minus 15 is a negative 11 over 1. All right, next problem. I got a graph. Okay, we got red graph is G, green graph is F. I want you to use the graph to find these derivatives. Find, let's see, how many? We got 2 of them. I want you to find H prime of 1 and K prime of 6. Go for it. All right, this is how I would do it. H prime of X, I'll just go over here so I have more room. Derivative of the first times the second plus the first times derivative of the second. So then H prime of 1 is F prime of 1, G of 1, plus F of 1, G prime of 1. So F is the one in green. At x equals 1, f prime is the slope of this segment is up 2 over 1. So that is 2. G of 1 is just the function value. So go up to g from 1 and over to the left, and that is 3. F of 1. F of 1 is 1, 2, is also 3 because they're actually intersecting there. That's kind of cool. And then g prime of 1, the slope at x equals 1 of g is a negative 1. So this is 6 minus 3, which is 3. All right, letter B, let's find k prime of x. It is low, d high, minus high, d low, all over low, low. So k prime of 6, let me scroll down just a little here. So and I'm going to be careful. I'm not going to try and write it out and evaluate it at the same time because I find these a little difficult with the graph. So f prime is 6. So I'm just going through and replacing all the x's with 6's. Okay, all over g of 6 squared. Oh, boy. All right. So g of 6. What is g of 6? G of 6 is 4. F prime of 6. No, it's not. Arg. G of 6. G is the red. G is red. G is red. Let me write it over here so I have that. And this is F. So G of 6 is 2. F prime of 6 is negative a half. F of 6 is 4. G prime of 6 is negative 2. All over g of 6 squared. Well, g of 6, what did we say was 2? So 2 squared is 4. So that's a negative 1 plus 8 is 7. This is 7/4. All right. Here's another practice problem. Given f of x equals x squared over x plus 1, I'd like you to evaluate the following limit. Please find the limit as x approaches 3 of f of x minus f of 3 all over x minus 3. Pause the video. Give it a try. Okay, well, I hope you didn't actually try and do this. Golly. You should be able to do it. I mean, my goodness, it'd be a lot of work. But instead, you should know that, what is this? What is this stuff? That's f prime at 3. So, let's find f prime of x. That's low d high minus high d low all over low low. So f prime at 3 is 4 times 6 minus 9 over 4 squared is 16. So 24 minus 9 all over 16. What is that? Like 15? 15 or 16. There it is. So, hey, be on the lookout of this. You know, the thing is that now that you know how to do the limit definition of now that you know how your derivative rules, you think you're not going to have to do this anymore. Well, that's not true. This is still an important part of mathematics, and we always go back to that. And whenever you're doing something new or different, you got to go back to your definition of the derivative. This is how the AP test will make sure you know it. They'll ask you questions like that. Now, they're not expecting you to do the limit. They're expecting you to do the derivative. All right, let's take a look at another one. Practice 4.4. Got two different graphs, f and g. And given these graphs, I want you to go through and answer each one of these. I think it might be a good idea to do maybe like A, B, C, and then, unpause the video and we'll check those and go from there. Or you can do all of them at once. It's up to you. But I'm going to go ahead and start going over them as if you've done all of them, but you can take it in chunks. All right. A. Find f prime of negative 1. Well, this is f over here, and at negative 1, the slope of f is up 1 over 1, because it's a line segment, so that is 1. Okay, g prime of 0. Where is g? Here's g over here. G prime of 0. The slope of this line is horizontal. Horizontal lines are a slope of 0, so that's 0. How about f prime of 0? Ooh, see how it starts to curve there? And it's straight here? This is not a smooth curve. Hope you realize this is a point. That is not smooth. It's continuous, but it is not smooth. It does not exist, or undefined, whatever you want to say. All right, it is not. You can say either one, actually. The derivative does not exist. It is not differentiable there. We're good to go. How about the limit as x approaches 1 of f of x? Okay. So really no tricks here, right? We just got to do the limit. The limit as x approaches 1 of f of x. Well, be careful now. As I'm approaching 1 from the left, I'm approaching 0. From the right, I'm approaching 0. The limit exists because the limit from the left, the limit from the right are the same, and they are both 0. I don't care what's happening at exactly x equals 1. This little blue dot up there, I couldn't care less. That is 0. E. The limit as x approaches negative 1 of f of x minus f of negative 1 all over x plus 1. Well, this is x plus 1. You know what that is. That's x minus a negative 1, right? So what do you think this is? Well, we just went over that a second ago. Hopefully you remember that is f prime at negative 1. F prime at negative 1. I think we already answered that. So this limit must be 1 because that's the derivative at negative 1. All right, back up to the top here. We've got k of x equals f of x times g of x. Find k prime of negative 1. All right, so first I'm going to find k prime. Derivative of the first times the second plus the first times derivative of the second. All right, so k prime of negative 1. I get k prime of negative 1. When does negative? Okay. Here, f of... Oh, I'm sorry. We need to do f of negative 1. F prime of negative 1. G of negative 1 plus f of negative 1. G prime of negative 1. Okay. F prime of negative 1. What is that? Oh, we already did that one. That's 1. G of negative 1. All right. Got to go G of negative 1. Here's G at negative 1. It's at negative 1. All right. Plus f of negative 1. What is f of negative 1? At negative 1, we're up here at 2. G prime of negative 1 is, well, that's actually 0. So the answer is simply negative 1, because negative 1 plus 0 is negative 1. All right. H of x is equal to f of x over g of x. Find h prime of 1. So let's find the derivative first. H prime of x is low d high minus high d low all over low low. So h prime of 1 is g of negative 1, f prime of negative 1 minus f of negative 1, g prime of negative 1 all over g of negative 1 squared. All right, g of negative 1, I think we've already done that, is g of negative 1 is negative 1. So this is going to be negative 1. F prime of negative 1, I recall, was 1. We did it over here at A. F of negative 1, we just did that a second ago. It is 2, so it's minus 2. G prime of negative 1, you can see it's flat. It's 0. It's 0. Over g of negative 1, which is negative 1, squared gives it a positive 1. So anyway, this becomes negative 1 over positive 1, so this is also negative 1. There we go. The limit as x approaches 2 of g of x. What is the limit as x approaches 2 of g of x? Well, as x approaches 2 from the left, we are approaching negative 1. From the right, we are approaching positive 1. So because the limit from the left is a negative 1 and the limit from the right is a positive 1, we have to conclude that this limit does not exist because they are not the same. What is the limit as x approaches 1 of f of x times g of x plus 1? All right, well, let's split this limit up. The limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x plus 1. So the limit as x approaches 1 of f of x. Can we evaluate that? Well, yeah, pretty easily. We did that earlier, right? The limit as x approaches 1 of f. From the left, it's 0. From the right, it's 0. So I think very confidently this is 0. Agreed? Now, the limit as x approaches 1 of g of x plus 1. So if I plug in 1 here, I'm really finding g of 2. So the limit as x approaches 2 is what this is really. Do you see how that would work? So that would give me negative 1. And that would give me positive 1. So this is either a negative 1 or a positive 1. So we need to think about this. Well, as I come from the left, it's going to be negative 1. But what's 0, the limit of f of x, times negative 1? Well, that's 0, right? Well, what about when I approach 1 from the right. So that would be when I plug in 1, it's 2. So I'm coming at 2 from the right. Well, in that case, it would be 0 times positive 1. But what is that? That is also 0. So believe it or not, this limit actually exists. It exists in this situation, even though this one doesn't. Because we're multiplying these two together, we have to conclude that the limit from the left is 0 and the limit from the right is 0. This is 0 times negative 1 from the left, 0 times positive 1 from the right, but that's still 0. And what is this? What is this old friend of ours? This is f prime at 1, right? F prime of 1. Can we figure out the derivative at 1? No, we cannot, because it is what? Not smooth. Oh, excuse me, it is smooth. It is not continuous. So this does not exist. All right. And that was a fun way to end it. Pretty challenging stuff there. Makes you think. Until the next video, I will see you around.